When you factor cubes, you've got a couple of formulas. So let me write them down here. The formula for x cubed plus y cubed, just two things cubed. It could be no, it could be one. It could be x cubed plus 8, which would be x cubed plus 2 cubed. You know how when we have the difference of two squares, if you get two numbers and you think they're cubes, you try to rewrite them in terms of a cube. Like I might say, oh, can I rewrite this as something cubed plus something else cubed? Well, that's what we'll do here in a minute. You'll see me talking about doing that. If I can write things as a sum of two cubes, I want you to think about something. Could we factor x squared plus y squared? Was that factorable when you had two squares added together? They weren't factorable. But cubes are. They're a little different. Here's how they factor. You say, well, whatever it is I cubed over here, when I cube x to get x cubed, and when I cube y to get y cubed, right? When I go to factor that, I take those things that I would have cubed, and it's x plus y times x squared minus xy plus y squared. That's the factoring formula. And I've never seen that second factor break down once you have a cube. Usually it just doesn't break down, okay, for some reason. Well, there is a reason that it makes sense, but anyway, let's not get into that right now. Now, if I have the cubes subtracted, it would break down into x minus y times x squared plus xy plus y squared. Anybody see a way that maybe you could remember that? It's a lot of memory things there. If there's a plus here, there's a plus in the two factors when you first take the two things and you add them together. Notice down here when there's a subtraction sign, the two factors are subtracted from each other. That's one thing that I remember when I'm looking at them. So if it's x cubed plus y cubed, it's going to be x plus y times some other stuff. If it's x cubed minus y cubed, it's going to be x minus y times some other stuff. Now I want you to look at what's in the second parentheses. The terms are alike. There's an x squared, there's an xy, there's a y squared, and it's both a plus y squared on the end, right? The only thing that's different is if you look here, here's how I remember it. X cubed plus y cubed. I'm going to say x plus y, and then I'm going to switch the sign on the very next thing. So there'll be a subtraction sign. If I have a plus here, the very next sign, operation sign between two numbers will be minus. On x cubed minus y cubed, there's a minus there, so there'll be a minus here. So then it'll be the opposite thing in between the next terms. It'll be adding instead of subtracting there. Hopefully, as we go through some of these, maybe it'll make more sense. Let's dig into a problem here. So the problem for number 7 was y cubed plus 64. Can I rewrite that as something cubed plus something else cubed? Yeah, you could cube y to get y cubed. What would you cube to get 64? 4. 4 times 4 is 16 times another 4 is 64. So you're going to have to recognize cubes here. Yeah, you might want to make a little list of them on your paper if you have a hard time doing that. So if I want to factor that, what the factoring pattern says is I take that y and that 4 and I add them together. And then I know it's going to be y squared. Because I had a plus sign here, I will have a subtraction sign in that second parentheses there. Now, now I'm going to multiply the two things together, the two things that were cubed together. So it would be y and 4. Wouldn't that be 4y when you multiply it together? I would write it as 4y. And then I'm going to add in the second thing squared. So what's 4 squared? 16. So that's how I would factor that one. All right. You might look at something and go, well, that's not a cube. That doesn't have a cube in it. But what should you always do when you're factoring? What's the first thing you should always do on any kind of problem you get? Yeah, see if there's a GCF. Does anything divide out of it? Yeah, a 3 does, and a Z. And if you do that, you're going to go, oh, look what's left. There's a cube, C cubed. 81 divided by 3 is 27. And then if you take the C out, that's all I'd have left. Isn't there a cube left inside that parentheses?
Also, 3 to the 4 is 81.
So what now?
3 to the 4 is 81.
Yeah, 3 to the 4 is 81. But what I'm going to end up doing there is because I divide that 81 by 3. It'll end up being a 27 there. So if I look at this, can I factor this c cubed minus 27? Sure, because I could think of this as 3c times something cubed. What's the something? C, in this case cubed, minus something else cubed. What would you put in that? What's cubed to get 27? 3. So my numbers that I'm working with, or my terms, are a c and a 3. So since it's a difference of two cubes, there's going to be a subtraction sign right here. It's going to be take the two things and subtract them, and then you're going to square the first thing. Since I had a subtraction sign in the first parentheses, there'll be a plus right here. It's like a minus and a plus, or a plus and a minus, basically. I'm going to multiply the two things together, the 3c, and then I'm going to always have a plus here, and at the end it's always add, then the last thing squared, so 3 squared is 9. And if you tried to factor that anymore, just doesn't work, okay? So that's how I could factor that. Okay. This one also is the sum of two cubes, and the reason I know is that I can rewrite them as something cubed plus something else cubed. Now the last one, the h cubed, it's easy to see that's going to be h, right? What can I cube to get a d to the 6? D2. You could say 6 divided by 3, I would need an exponent of 2, so I'd want a d squared in there. So I've got a d squared and I got a h. You can kind of see once you get it in there that it would work. Again, to figure out that should be a d squared, 6 divided by 3 would be 2, so I could use a d squared there. So I've got a d squared and an h. So if you think about it, what we're going to do, we're going to have a plus sign here. We're going to put the d squared in the h. Now over here, because there's a plus sign there, I know there's going to be a subtraction sign. The other one's always a plus, so I'm just going to put them in. That way we've got our adding and subtracting taken care of. Now I'm going to square the first term, the d squared. D squared squared would be d4, right? Because 2 times 2 would be 4. Then I'm going to multiply the two things together, so d squared times h would be d squared h. It's going to look like that. And then I'm going to square the h, the second term I had, so it'll be just h squared. And that would be as far as I could go with that. Let's go ahead and multiply this. We're multiplying this out just so we can kind of see that it works. So we have, that'd be actually a minus. A positive times a negative is a minus d4h, and then we would have plus d squared h, right? Now let's distribute the h. I'll use a different color. H times d to the 4th would be plus h d to the 4th. Oh, look, that one is going to cancel that one out, right? And then plus h times minus d squared h would be minus d squared h squared. And then plus h, I'm missing some terms here, it looks like. No, here we go, okay. Plus h times h squared would be h cubed. What did I do? Did I mess something up? When I distributed, let me put it in green. Here's where I messed up. When I said d squared, this term here, times h squared, shouldn't that have been a plus d squared h squared? Mm-hmm. Okay, so these two actually cancel each other out. So what am I left with? D to the 6 plus h cubed. So you can see it works if you multiply it out. The problem is, isn't it easy with something like this to mess up the multiplying? I did it. My mistake was when I did the green multiplication. Okay. One of the reasons I want to jump to 53 is one of the things that's covered in this section is factoring by grouping, and we kind of did that the other day because we did that splitting the middle term that's also in this lesson, but I want to show you one where it would just be normal to factor by group. Most of the things that I'm given so far have had 2 terms or 3 terms, right? What do you do if there's 4 terms? That's when you actually do, we did this as part of our splitting the middle term yesterday, but if you ever had 4 terms like this, you'd first check to see, can I put any terms together? Are they just messing with me and not simplifying some stuff? But here they're not. So anytime I have 4 terms, we're going to do this. We're going to do part of what we did in that yesterday when we worked with splitting the middle term. I'm going to group these 2 together. And I'm going to group these other 2 together. And I'm going to say, okay, look at the red pair. What is the GCF of the red pair? What's the biggest thing that divides out of those 2 numbers? Would it be an x squared? Because you got a 5 and a 6. That's not going to simplify. There's nothing in common for a 5 or a 6. But couldn't you pull an x squared out of those 5x cubed plus 6x squared? And when you have 5, if you divided that out, 5 would be left. I had an x cubed. I took an x out. There would be an x left, right? And then I have a plus 6x squared, but I took the x squared out. Wouldn't it be a 6 there? Okay. Now here's what I want to really point out. So make sure you're paying attention here. When I get to this slot, if there is a negative there or a subtraction sign, I got to factor out the negative. If I don't, this isn't going to work out for me. So this happens a lot when you break things down. I just don't know if we ran into too many of them yesterday. I know I did an additional video or two that I posted, and in one of those it actually happened. I just want to make sure we did one today. When I have a subtraction sign there, remember, I got to have those two parentheses match up, don't I? So in order to get them to match up, you always have to do this. If there's a subtraction sign there, factor out a negative. What would divide into both 45 and 54 in that second set? What are they both divisible by? Huh? 9. So I can take a 9. I'm going to actually factor out a negative 9. So negative 45 divided by negative 9 would be a positive 5. That's a good thing. Look in our other parentheses. It matches it so far. And there was an x left over. And then I say, okay, well, I got negative 54 divided by negative 9. Wouldn't that be a positive 6? Do you see why I had to take the negative out to get the parentheses to match? Because my goal and all that was always, even yesterday when we were doing part of this process, if these two things don't match, it didn't help me to do this process. Okay, so the things that I circled in green, that's my new GCF. Because I have one monster big term here and another monster big term here. You could look at it that way. Those 4 terms turned into 2 terms because I took a GCF out. But both of them have that 5x plus 6 in them. So that's our new GCF of our 2 monster terms, I guess we could call it. And then what would I have left? Over here I had an x squared left, and over here I had a minus 9. So I factored it, but am I finished? No. What do you see up there that will still factor? Well, it's not like this 5x plus 6 is okay. I can't really... Yeah, isn't this a difference of 2 squares? Couldn't I rewrite that as x squared minus 3 squared, right? So if it's a difference of 2 squares, if you remember, you write the x and the 3, and on one of them you put a plus, and on the other you put a minus. So a lot of times when you're factoring, you got to look at what your result that you get, because it might be that one of those might keep breaking down, and you're always trying to break stuff down. Because honestly, we use factoring to actually solve equations, and on our graphs, our equation solutions are always our x-intercepts. So whether we're graphing or solving, this is the handy thing to have happen.